Our objective for today, I can factor quadratic trinomials. Read together. 1, 2, 3. I can factor quadratic trinomials. So today we're starting a new concept. Tell your neighbor the new concept, please. Okay, I didn't say the objective. I said the new concept. Oh, quadratic trinomials. Yes. Even though it's a new concept, it's one that we already did at the beginning of the school year. Remember when we introduced polynomials and classification? Yes, you should know what it looks like by now. So in your Freire model, stay focused, my goodness. In your Freire model, you're going to write quadratic trinomial. What is a quadratic trinomial? An expression of three terms that highest degree is 2. Example: x squared plus 3x plus 2 and x squared plus 8x plus 7. Copy that, and then I'll elaborate on the definition. Copy that. All right, here we go. According to the definition, it says expression of three terms with highest degree 2. So we have an expression here. Yes, an expression here. Yes. Do they have three terms? 1, 2, 3. 1, 2, 3. Yes. Highest degree. Let's check for highest degree. What is the degree of this term? 2. This term? 1. This term? 0. Highest degree is 2. That is correct. Degree for this one? 2. This one? 1. This one? 0. Tell your neighbor why this one is degree 0. Does not have a variable, because we're going by the exponents on the variables, right? Yeah, that's why it's 0. So the highest degree is 2. Yes, expressions and 3 terms. That's why it's called a quadratic trinomial. Remember when we classified polynomials? Yes. Let me show you some non-examples. Copy these. X squared plus 3x plus 2 equals 0. Negative 3 plus x equals 10. 2 equals 2x and x squared. Copy those. As you're copying them, start thinking, these are not quadratic trinomials because blah, 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 blah. Okay? Check with Mary on why those are not quadratic trinomials.
The first two, because they are, yeah, and the last one is just by itself. Or it's not a trinomial.
Alright. Let's see, Maria, why are these not quadratic trinomials? Because they're what? Equations. And right now we're looking at what? Expressions only. Okay. However, if you look at this one, technically it is, except for now it became an equation, right? We're going to get into that later on, but for right now we're looking at expressions only. How about this one? Ryan, why is this not a quadratic trinomial? Yeah, these have one variable. Okay, Ian. It's a monomial. It's only got one term. How many terms do we need, everyone? 3. So this is a quadratic monomial. And we're looking at what? Quadratic trinomial. So therefore, hashtag your BFF that's not in this class. Send them a picture and tell them hashtag what is a quadratic trinomial. Get us started, please, Stephanie. What is a quadratic trinomial? Hashtag what? Expression only. Expression only. Hashtag what, Nate?
Trinomial.
Damn. Trinomials. And hashtag what? We're left with one. Jerry. Yeah, that's a trinomial. Hashtag Kylie. we got expressions, we got trinomials. Go ahead, Ian. Yeah, we got trinomials for 3 terms, and we're missing, Leslie R, highest degree 2. Hashtag BAM. Okay? Next, underneath, you're going to write steps. And for steps, you're going to come up with those in a little bit as we go through the process. Okay? However, I do want us to get some practice. Instead of using algebra, we're going to use geometry today to get started. Okay? So to get us started, could I get the third person on each row? Go get a baggie of tiles for your row, please. They're in the back. Thank you. No, it's cool. What? Anyway, get the tiles out. Turn your paper over. In the back, I want you to write example mega Q. Example mega Q. But get those tiles out because we're going to be using them. And let's refresh our memory. Let's see. Get this one in front of you. It's a blue square. Who remembers the name of that tile? Very good. X squared. And if I turn it over, it's negative x squared because it's red. You guys remember that? No? Oh my goodness. Yeah, we saw this at the beginning of the school year when we covered polynomials, some of it. Alright? Next, if I get this one in front of me, the green one, remember the name of that one? X, that is correct. And if I turn it over, that is negative x. Alright? Next, if I get a yellow one, what do we label that? 1. Yeah, because it's 1. But if we turn it over, it's negative 1. Alright, so now that we know the name of these, I want you to get me in front of you one of these, 3 other rectangles, green, and 2 of the yellow. Alright, so what do we have in front of us? We have a polynomial. On your paper you wrote example mega Q. Tell your neighbor the polynomial that we have here. Go ahead. Bless you. Alright. Jaylene, what do we have? X squared plus 3x plus 2. Hands if you agree with that. That is correct. This is a polynomial. Like I said, we're going to be using geometry. So, we're going to factor this. So you're going to draw an arrow like this and open 2 parentheses to get our factors. Yes? But in order for that to work, we first need to do something with these tiles and set them in a certain order. So let me ask you to do something. Look at the tiles that we just got out. I want you to make a rectangle. Get those tiles, make a rectangle, but you cannot leave any gaps. So try to make a rectangle using those. without leaving any gaps. Go. I'll give you some time.
Oh, wait.
Now some of you started doing this, like some of you did like, oh, I got it. Well, there's huge gaps in between.
I made them.
Alright? Alright, here you go. Now, I know some of you already saw it, some of you didn't, so check this out. Here goes the rectangle. Hands of you did that. Now, some of you did this. Is that also a rectangle? Yes, that also works. That's right. But from now on, whenever I ask you to get a rectangle done, keep all the yellows together. All the yellows together. Everybody got it? All right, so everybody form a rectangle like mine, please. Everybody done? All right, here we go. So once again, we started with example mega Q, and we said we have x squared plus 3x plus 2, and we're going to come up with our factors, yes? So check this out. I want you to draw this picture on your paper, and I'll help you do that. So you're going to draw a rectangle like this, and then one line down here, and one line across like this. Focus, please. So we do this here. Do you guys see it? Alright, so watch. Look up, please. What did we say was the name of this one? X squared, yes? Don't label it yet. I'm just doing this one on mine. This one is x, this one is x, this one is x, this one is 1, this one is 1. Are we there so far? So on your paper, label this one, x squared. What would be this space right here together? 2x. 2x. What is this space right here? X. And this space right here? 2. Now let me show you how to factor using geometry or the area model. Watch. This is a square, is that correct? So this side times this side gives me x squared. So what does each side measure? X times x gives me x squared. That is correct. Next, x times what gives me 2x? X times what gives me 2x? 2. Because x times 2 is 2x. X times what gives me x? 1. So, look at this. What do we have here? 1 factor, 2 factors. So my factors are x plus 1 times x plus 2. And we just factored a polynomial using geometry. How we doing? Okay? I know, right? Now, some of us that are very good at algebra, some of us are actually going to struggle with this kind of math, because this is spatial math. A little bit different. Okay? But try. Let's do another one. Get in front of you, let's see. Get 1 big square, blue one. Let's get 5 green ones. Get 5. And 6 yellow ones. Alright. Let's see. Tell your neighbor the polynomial that we have in front of us. Okay. Go ahead, Shaden. What do we have? X squared plus 5x plus 6. Hands, have you got that? Okay, so you're writing that down on your paper, and then you're going to open two parentheses in order to get our factors. But now I'm going to let you do this one by yourself. Make a rectangle out of those tiles and draw your rectangle on your paper and come up with the factors. Ready? Go. I'll give you some time. Remember, the key is keeping the yellow ones together. Okay, let's see. Who did something like this? Keeping the yellow ones together. Bless you. Just kidding. That was good, wasn't it? That was good. No? Hands, we got something like that? Okay. So, let's see what we got. We had x squared plus 5x plus 6, and we're going to get our two factors. But before that, I'm going to draw my picture on the side. Here's a rectangle. Line down, line across. What goes here? X squared. What do I label this one right here, everyone? 3x. What do I label this one? 2x. And what do I label here? 6. Okay, we know that x squared is x times x, yes? So x times what gives me 3x? 3. X times what gives me 2x? Plus 2. So my factors are x plus 2 times x plus 1. I mean, x plus 3, sorry. How we doing? Good? Alright, do one more. Last one. So we can go into some algebra. So get in front of you a big square, 2 green, and 1 yellow. Do this one completely by yourself. Write the polynomial, make a square or a rectangle, get me my factors. Go. $40 seconds. Should be just about done. Let's see. No? Nobody? Alright. You got it? Okay. And if you got something like this, alright, good. Therefore, our factors are, hold on, let me write it out. So, we have x squared plus 2x plus 1. My factors are x times x. This is 1 and 1. Is that correct? X plus 1 times x plus 1. However, that is written x plus 1 squared. Hands if you got that. That is correct. We got this? Alright, put your tiles back in the baggie. So we're done with geometry piece. Now we're going to go into just pure algebra. Okay? So, on your paper, write down example Q and copy this down, please, after you put away your tiles. Now, I just wanted to introduce it using tiles so you can see a different way of approaching factoring. But now we're back to doing algebra. It says, example Q. Factor each trinomial and check your answer. X squared plus 15x plus 36. Copy that, please. I'll give you 30 seconds. Go. Alright, here we go. Writing utensils down, look up to the screen. Now, I'm going to show you a new method of factoring. So I need you guys full attention up here. Here we go. Stop fiddling with the tiles. You can do that at the end. Stop taking notes. I want you to focus just on the example. I'm going to do a think aloud. Think about what I'm talking and think about what I'm writing down. Okay? Because you're going to be following along the same process. Here we go. Think aloud. It says, factor each trinomial first. Okay, I've done factoring trinomials all week, and I know the first thing I need to do is check for GCF. Let's see. There's none, so I'm assuming it's just one. But I don't want that kind of factoring. I want two factors in parentheses. So I'm going to do a new method that I know. The new method is called using a diamond. There it is. However, that's going to be too much to do every time for each problem. So to simplify it, instead of making a diamond, I'm going to erase all this and leave it like this. And I'm just going to call it a Power Ranger. Alright, so now that I have that, I'm going to use parts of the polynomial to find my factor. So let's see. I'm going to use the last part, last term, and I'm going to write it on top. 36, that's going to be my product. From there, I'm going to write my middle term on the bottom, and that's going to be my sum. So now I need to find factors of 36 that add up to 15. Oh, kind of like the warm-up, yes. Let's see, factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Let's see, which one of those adds up to 15? Well, not this one, it's too far apart. Not this one. Not this one. Not this one, therefore it's 3 and 12. 3 times 12 is 36, 3 plus 12 is 15. Okay? Now that I have that, what am I going to do with that? Okay, I'm going to rewrite this. I'm going to write the first term, the last term, and in the middle, instead of writing 15x, I'm going to write 3x and 12x. Does that give us 15x? Does this look familiar? Yes, now I can use grouping. What is GCF for these two? X, and I'm left with x plus 3 plus. What's GCF for these two? 12, and I'm left with x plus 3. What's my GCF for those two terms? X plus 3, and what's left over? X plus 12, and those are my factors. Copy that, please. You're like, what just happened? Copy that, please. So as you're finishing up, let me backtrack on my process again. I looked at the trinomial, and if it's factors of the trinomial, the first thing I needed to check for was to see if there was any GCF. Okay, there wasn't. Therefore, I'm using my Power Rangers. There it is. The last term goes on top. That's my product. The middle term goes on the bottom. That's my sum. So, factors of 36 that give me the sum of 15, I wrote them out. Here it is. And I went eliminating, so I found that it was 3 and 12. Next, I rewrote the trinomial, but I wrote the first term and the last term, and the middle term, instead of 15, I wrote 3x plus 12x. Now I have a 4-term polynomial, which allows me to do grouping. Now, factoring by grouping, I already know how to do. Find my GCF, GCF again, and my factor. Tangibly, we got it up to right there. Yes? Okay. However, what's the last part that they're asking us to do? Check. So we're going to write check, and the way I want you to check it is by using the area model. What's my first factor? X plus 3, that goes here. X plus 3, line across. And then x plus 12, line down. And let's multiply. What is x times x? X squared. What is x times 12? 12x. Done with those two. So then 3 times x, that's 3x. 3 times 12, that's 36. Alright, let's combine like terms. Let's see. Is there another x squared? No. Bring it down. X squared. These are the same, so draw your peanut. 12x plus 3x, that gives me 15x. And then bring down your 36. Did we end up with what we started? Yes, and that's how we check. I know, it's a lot of stuff, right? But now we're putting together everything that we've learned in regards to polynomials. Okay? Example 1a. Copy this one. We're going to do this one together. See if we can go a little bit faster. Here we go. Don't copy the instructions. Just write example 1a. X squared plus 10x plus 24. Let's see. Let's go through our process. Step 1. What do I need to do first? Find GCF. There is none. Okay. Step 2. Draw your Power Ranger. There it is. Which number goes on top? The last one, which is 24. That's our product. What number goes on the bottom? 10. It's the middle term, and that's our sum. So I'm going to write out all the factors of 24 just to have them handy. 1 times 24, 2 times 12, 3 times 8, 4 times 9, and 4 times 6. I did that on purpose here if you're paying attention. 4 times 6. And then they repeat, right? So which pair of those adds up to 10? Not this one, it's too far apart. Not this. Oh yeah. This one. My bad. Not this one and not this one. So we're going to write 4 and 6. So from there, we're going to rewrite our trinomial. We write the first term. We write the last term. And instead of 10x, we're going to break 10x into what? 4x plus 6x. 4x plus 6x. Do we know how to do factoring by grouping from there? Yeah. Group the first two. Group the last two. What is GCF for the first two terms? X, and we're left with x plus 4 plus. What is GCF for the last two terms? 6, and we're left with x plus 4. What's GCF again for both terms? X plus 4. And what do we have left? X plus 6. And these are my factors. Do we know how to check? For right now, let's skip the check. Let's go for another practice. Do this one completely by yourself. Example 1b. Don't ask your neighbor. Don't look over. Try to do it completely by yourself. Go. X squared plus 7x plus 12. Seconds. Ten. 9. 3, 2, 1. Check with your neighbor, see what they got. you. Bless you. Bless you. Alright, here we go. Help me out, Leslie C. What is the first thing we check for? CCS. Was there any? No, other than one. Next, Power Rangers. You draw your Power Rangers. What goes on top? 12. That's our product. What goes on the bottom? That's our sum. And our factors are 12 are 1 times 12, 2 times 6, 3 times 4. Which one of those adds to 7? 3 and 4. So we write x squared plus 3x plus 4x plus 12. Group them. This is x. We're left with x plus 3. And this is plus 4. X plus 3. CCF is x plus 3. And the other factor is x plus 4. My factor. And we know how to check, yes? Yes. Well, the order matters. In multiplication, what property allows us to move it around? Commutative property, so it doesn't matter. As long as you find your two factors, it could be 4 times 3 or 3 times 4. Okay, do this one. Example 1C. Let's see how you do. X squared plus 6x plus 5. 30 seconds. Just about done. 5, 4, 3, 2, 1. Okay, give the factors to your neighbors, see what they got. Okay. Factors. Mia, what'd you get? X plus 1 times x plus 5, or x plus 5 times x plus 1. Hands if you got that. That is correct. Those are my factors. Let's kick it up a notch, yes? Ha 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 ha. Copy this one. Example 2a. X squared minus 8x plus 15. Do this one together. Let's go a little bit faster. What do we check for first? CCF. There is none. Power Rangers. What goes on top? 15. That's my product. What is my sum? Negative 8. Factors of 15 are 1 times 15, 3 times 5. What factors of 15 give us 15, but when you add them, give us negative 8? What is it? Negative 3 and negative 5. Negative 3 times negative 5 is positive 15. Negative 3 plus negative 5 is negative 8. So my new polynomial is x squared minus 3x minus 5x plus 15. Group. Don't forget to include this negative in the second parenthesis and put a plus. X minus 3. This is negative 5. X minus 3, my factors are x minus 3, x minus 5. Factors. Some of you fingers how comfortable you are with these? Okay, not bad. 4, 3, 3, 5, 5, 5. Alright, home plate for tonight is on pages 538 and 539 only. There is tutoring if I don't see you. See you guys tomorrow. Bye. Have a good one.